Hey everyone, welcome back. Today's day 6 of my 30-day FAANG grind, and I'm solving 6 to 10 LeetCode problems daily, explaining them on video, and sharing with all of you on YouTube. I'm Divya, by the way. I've interned at Massachusetts Institute of Technology, where my area of focus was on statistics and machine learning. Currently, I rank at top 0.3% on LeetCode, and like most of you, I love doing LeetCode DSA problems. Previously, we have already covered problems based on sliding window, two pointers, prefix and suffix based problems, and also problems based on strings and problems based on stacks. Today, it is all about binary search, which is one of the most powerful and versatile techniques in coding interviews. In this video, we'll go beyond just finding a target and we'll solve problems based on rotated arrays, lower and upper bounds space, and problems based on binary search on answers, and much more. Before I begin, if this content is helping you out, please smash that like button, hit subscribe, and share it with your friends. Let's go. The problem that we're tackling today is LeetCode 33, search in rotated sorted array. We have been given an array which is initially sorted, but then it was rotated by some number of times. And upon rotation, now our objective is to find a target value in that sorted rotated array. Previously, we tackled a problem based on sorted rotated array, and this is pretty much identical to that problem. So this is the example and these are the constraints. Let us go to the dashboard where we will try to investigate and find an optimal solution for this problem. Cool. Now we are on the dashboard and this is the array that we have been given and this is the target. So what is the brute force approach that comes to our mind? The brute force approach will be, hey, scan from the left hand till the right and find the target and find the target value. If at any point you find the target value, please return the index at which it is present. But if suppose the target value is not present within this entire space, in that case, we'll just return -1. Awesome. As you might recall from my previous video, there was an observation that we made. And the observation was, if an array is sorted and if it is rotated, then there will be at least one part in that array which will be sorted standing from the midpoint, okay? And keeping that observation in mind, we'll try to solve the problem for today, and we'll try to find or realize a few cases, and we'll try to see how it all comes to be. So the first case will be this case, okay, where we have left pointer, mid pointer, and right pointer, and we see that standing from the mid, this region is sorted, okay? And if this region is sorted, we ask ourselves, hey, if this region is sorted, is the magnitude of target available in this region? Does the value target, is it bounded within this region or within these two ends? If that is the case, then we are pretty much certain that our target value will lie within this space. In that case, what we are going to do, we are going to shift the right pointer to mid -1, thus neglecting the right space, which will be of no use for us. That is case number one. There can be a different case, and that case can be this region is sorted from left to mid, but our target value might not lie in this region. In that case, what we are going to do is we will move our left pointer from here to mid +1. Thus, we'll just focus on this region where the target value has a possibility of lying. Thus, we'll just neglect this entire region upon moving the left pointer to mid +1. Okay. Now, there can be a separate case, and that case can be the region from mid till R is sorted. And if that is the case, and if our target value, if it lies between those two bounds over here, somewhere in between, in that case, what we're going to do, we'll just neglect the left space because that will be of no use to us. And we'll just move our left pointer to mid +1 and we'll make a scan from the remaining space of our array, okay? Similarly, the last case can be pretty much similar to that. This region is sorted, but the target value will be present over there. In that case, what we're going to do, we'll just move our right pointer to mid -1 and we'll make a scan from these two bounds. Okay, cool. So that was all there was to visualize. Now let us go to the code section and we'll see how it has all been materialized. First of all, we declared the low pointer to the left hand, right pointer to the right hand. Then we have this while loop. Then we have this mid value thing that comes from the low and high pointer. Okay. Then at the mid value, we ask ourselves, hey, does this equate to target? And if that is the case, then we return the index, which is the mid index. So but if that is not the case, then we'll try to scan the part where the array is sorted. We know from our observation earlier that if an array is sorted and if it is rotated, then there will be at least one part that will be sorted. And these are the two methods in which we will find that part. Okay. The first method asks us, hey, if nums of low, hey, if it is lower than the mid part, it will entail and it will tell us that this region between left and mid is sorted if this statement comes to be true. However, if this statement comes to be true, in that case, our sorted region will be between mid and R, inclusive of both those two ends. Let us look at this first region, if that comes to be true. If the region from left hand to the mid end, if it comes to be true, let me scroll you back. What happened then? There were two cases. The first case was target lied over here in the sorted region. The second case was target did not lie in the sorted region, but it lied somewhere in the non-sorted region or in a different region. Okay. So that is what we are doing over here. This condition checks if the target lies in the sorted region, and this condition tells us if the target do not lie in the sorted region, then what we have to do. If the target lies in the sorted region, in that case, we'll just neglect the right part, move the right pointer to mid -1. This is exactly what we are doing. We are moving the right pointer, which is high over here, to mid -1. However, if the target do not lie in the sorted region, in that case, we'll just move our left pointer to mid +1. And it is precisely that we are doing over here. We are moving our low pointer, which is the left pointer, to mid +1. Okay. And the second part is something that checks for the sorted region on the right part, which is something like this. Okay. It asks us, hey, if nums of mid, if it is smaller than nums of high, if that is the case, then the region between mid and high, it is sorted. And if that is the case, then there will be two cases. The first case will be target lies within that boundary. And the second case will be the target do not lie in that boundary, something similar to the first case part 2. Okay. If the target lies in that boundary, then what will happen? We'll move our left pointer over here to mid +1 because we will not be needing this space anymore because target lies over here, okay, in the sorted region. That is what we are doing over here. We moved the left pointer to mid +1, and if the target region did not lie in this region, if the target value, if it did not lie in this region, but if it lied somewhere here, in that case, what we're going to do, we'll move our right pointer to mid -1. And that is precisely what we are doing over here. We moved our right pointer, which is high, to mid -1. And this process will go on and on and on until either we find the value over here or our condition it violates. Means left and right pointer or low and high pointer, they switch their places, they flips, okay? And once this entire loop exhausts, we come out and return -1. But if we at any point we find the answer, we'll return from this statement, which will be executed, okay? And it will return the index. The time complexity is logarithmic, space complexity is constant because of this thing. We just need two variables. Time complexity is logarithmic because of the binary search that we are going through, okay, in this code. So yeah, that was all there was to this problem. I hope you understood my explanation. Let us go to the LeetCode dashboard where we'll try to submit the solution and see how it goes. This is the dashboard. I've already copied and pasted my solution. So I'll just submit it over here. And as you can see, the test case is passed and my solutions has been accepted. And you can go through the code. I will just scroll it up and down. Just give me a second. Yeah. Line number 7 and till line number 12, it deals with the left part being sorted. And from line number 13 to line number 18, it deals with the part where the right part is sorted. Awesome. So that was all there was to this problem and the solution. I hope you understood everything. If you still have any doubt, please feel free to ask me in the comment section, and I'll be much more happy to answer you there. Bye-bye.